Direct energy weapons are transitioning from conceptual science fiction to active frontline deployments across the U.S. Navy. To keep pace with the latest in high-tech military hardware, subscribe to the channel. Modern maritime operations face a specific asymmetric threat: the proliferation of cheap, expendable attack drones and small motorboats. Arleigh Burke-class destroyers rely on vertical launch system cells to counter threats, limited to roughly 90 missiles per ship. Once exhausted, the ship must leave the combat theater, as these cells can only be restocked at friendly ports with specialized gear. Firing a multi-million-dollar single-use interceptor to destroy a $20,000 drone creates a significant economic disparity. Without a reusable, low-cost defensive layer, a fleet risks being logistically and financially overwhelmed during an extended conflict. The first tier of this defense is the Optical Dazzling Interdictor, Navy, or ODIN, which is already installed on multiple active destroyers. ODIN is a low-powered laser designed to function as a dazzler rather than a destructive weapon. The system targets the electro-optical and infrared seekers on incoming weapons, blinding the drone and throwing it off its flight path. It is also used to neutralize surveillance sensors on aircraft, surface ships, and submarine masts, preventing an enemy from tracking the fleet's movements. While ODIN provides an infinitely reloadable counter to surveillance and targeting, it lacks the raw power to physically destroy an incoming threat. For physical interception, the Navy uses the high-energy laser with integrated optical dazzler and surveillance, HELIOS, currently deployed on the USS Preble. HELIOS is a 60-kilowatt class laser weapon. It is fully integrated with the ship's Aegis Combat System, allowing it to work in tandem with the ship's existing sensors. This 60-kilowatt output enables a hard kill, moving beyond sensor disorientation to the physical destruction of the target. HELIOS can knock small drones out of the sky and is capable of burning holes through the hulls of fast inshore attack craft. This provides the lethal, low-cost per-shot magazine depth required to thin out incoming swarms before they reach the ship's perimeter. Despite these capabilities, the Navy cannot rely on lasers alone. These systems are bound by the constraints of physics that traditional missiles are not. Atmospheric interference is the primary hurdle. Rain, fog, and sea spray scatter the laser's light, which sharply degrades its effective stopping power. In contrast, radar-guided missiles maintain their ability to track and destroy targets in zero-visibility weather conditions. Another requirement is dwell time. Unlike a missile, a laser must dwell on a specific spot for several seconds to burn through a target. This creates a speed bottleneck. A laser may not cycle through multiple incoming targets fast enough to stop a swarm. These environmental and temporal restrictions prevent lasers from matching the rapid-fire reliability of kinetic munitions. Range remains a major limitation. Current naval lasers have an effective engagement distance measured only in single-digit miles. This short range restricts lasers to a close-in, last-resort defensive role, as they cannot engage targets at the long distances covered by traditional missiles. Engineering constraints also limit performance. Firing high-energy lasers draws significant power and generates intense heat, which can prevent the system from making rapid follow-up shots. Furthermore, these weapons rely on delicate optical components that are difficult to maintain in harsh, corrosive maritime environments. Lasers offer a reloadable inner layer of defense, but they function as a complement to the traditional missile arsenal rather than a replacement for it. Thanks for watching. Let us know in the comments how you think directed energy will impact the future of the fleet. Please like, share, and subscribe for more videos.